Artificial intelligence is weaving its way into the absolute core of global business operations, taking on increasingly complex workflows. This chart highlights a strange reality. We see global AI market projections heading toward $50 billion by 2030, but simultaneously, enterprise trust in the technology is actually dropping. The drop in confidence comes down to reliability. Large language models operate as black boxes. They hallucinate facts with total confidence, and clever users can easily bypass their safety restrictions. Deploying unpredictable systems across thousands of daily enterprise operations turns a theoretical corporate asset into a massive, unmanageable corporate liability. If you are deciding how to deploy AI, you face a hard choice. You can roll out standard, off-the-shelf models quickly and cheaply, or you can spend heavy capital building custom, highly verifiable systems. Relying on simple prompt and response chatbots is a dead end. The systems actually driving business value rely on structured reasoning and multi-agent workflows. To separate actual return on investment from the noise, we are going to evaluate three specific implementation vectors. First, verifiable reliability. Second, autonomous agents. And third, simulation sandboxes. Your choice here dictates whether you are paying for a fleeting corporate novelty or if you are building durable, long-term infrastructure. Let's look at verifiable reliability. We are seeing a shift away from models that immediately spit out text, moving towards systems that first build structured reasoning graphs. In regulated fields like law and medicine, incorrect answers carry severe consequences. These new systems map out evidence and organize logical relationships before forming a single sentence. Comparing retrieval methods, standard embedding systems show hallucination rates around 30%. Knowledge graph systems cut that down to 15%. By converting raw patient notes into structured data, unsupported claims drop to 8.4%. Additionally, building argument graphs from scientific papers reduces token usage by 80%. The trade-off is friction. Achieving this reliability requires intensive upfront data engineering, which drastically slows down your initial deployment timelines. Accuracy in a high-stakes environment requires expensive structural investment at the architectural level. Better prompts will not fix a flawed foundation. This brings us to internal security, specifically mechanistic safety. Instead of trying to filter bad outputs, researchers are targeting the specific activation patterns that jailbreaks trigger inside the neural network itself. Looking at this security visualization, you can see standard attack success rate sitting at 61%. By blocking unsafe behavior directly at the representation level, that success rate plummets to just 2%, while preserving 94% of normal user prompts. But to do this, you need white box access to the model's architecture. You cannot implement mechanistic safety on a closed third-party API. True enterprise security means you have to look inside the model's brain. For organizations dealing with sensitive data, power is shifting away from simple API wrappers toward open-weight architectures. Our second investment vector is autonomy. We are moving past single models that generate text and moving toward multi-agent frameworks that coordinate entire workflows. When you allow AI systems to set goals, break them into subtasks, and collaborate with other agents, benchmark performance on the most difficult problem sets actually doubles. Autonomy is extending into the physical world through vision-language-action models, which combine visual understanding, reasoning, and physical actions into one system. This chart tracks robotic performance on previously unseen tasks. When a robot can narrate its own decisions and explain why it acts, success rates nearly double, jumping from 32% to about 62%. The operational cost here is hardware. Processing spatial environments, vision, and language simultaneously requires massive, continuous real-time compute power. When you deploy autonomous systems, your primary engineering bottleneck is no longer the model's intelligence. It becomes building the complex infrastructure required to handle inevitable real-world errors. Our final investment vector involved how these systems learn. Training is moving out of static datasets and into generative digital twins. Researchers are building autonomous twin loops. Real-world sensors continuously feed data into a virtual replica, allowing reinforcement learning agents to train inside a constantly updating simulation. This flowchart illustrates the payoff. By running millions of virtual miles before touching a real road, organizations reduce real-world testing needs by 40%, and the collision rate drops from around 25% down to roughly 10%. But a simulation is only as useful as its physics engine. Before you can train a single agent, you have to spend heavy capital building a perfect one-to-one virtual replica of your environment. Paradoxically, the fastest and safest way to deploy reliable AI in the physical world is to spend your budget building a highly accurate virtual one. Let's map these technologies by implementation effort and immediate impact. Autonomous twin loops and structured graphs sit top right, high cost but delivering verifiable reliability. Mechanistic safety falls top left, securing systems without tearing down infrastructure. Hybrid quantum AI sits bottom right, reducing computing overhead. Just monitor it. The defining feature of AI's next phase is friction. Getting real value out of these systems means embracing difficult structural changes to data architecture. If you operate in a highly regulated industry like law or medicine, relying on base models is a liability risk. Your immediate focus should be investing in structured argument graphs to ensure accuracy. For industrial and robotics leaders, generative digital twins are no longer optional research and development. They are the baseline requirement to stay competitive. And for general enterprise software, the transition needs to start now. Move away from single prompt interfaces and start testing multi-agent workflows. Artificial intelligence is making a strict transition from being a simple answer machine into core operational infrastructure. If your organization's entire AI strategy relies on writing better prompts, you are optimizing for an era that is already over.